1.3, how do I recognize the various number properties? So the do now, Dave was told the letter E stood for E equals 2.71828, etc. He thinks it is rational. Is he right? Explain why or why not. Okay, so Dave is incorrect. Because it is a non-repeating and non-terminating decimal. Which makes it irrational. All right, so we're going to review different types of number properties that you are very familiar with. So the commutative property. The commutative property states that A plus B is equal to B plus A. That's simple. You just remember to change the order. The associative property is also good under multiplication. So you could do A times B equals B times A. The associative property does not change the order, but changes the grouping of the numbers. So if you have the quantity A plus B plus C is equal to A plus the quantity B plus C. Change the grouping. The associative property also works under multiplication. So the quantity A times B times C is the same as A times the quantity B times C. You have the distributive property. The distributive property works over addition and subtraction. So if you have A times the quantity B plus C, that is equivalent to A times B plus A times C. Or A times the quantity B minus C equals A times B minus A times C. So you distribute the numbers, you kind of pass out and hand out the numbers. So ways to remember is you hand out numbers. And the next is closure. Closure was addressed in your Barron's book for a little bit right at the beginning. So we're going to write down the idea of closure on the left side over here. So closure is a set of numbers is closed for an operation. The operation could be adding, subtracting, multiplying, or dividing. If the answer is always a number that belongs to the same set. Okay, so if you have some room, you want to put that on your sheet. So an example here would be, say I have a set. My set contains A, B, and C. That means any operation, so any operation I'll illustrate as an asterisk, on A and B would produce C. So an operation on two numbers in the set produces a number in the set. So the idea here, the ways to remember is you end with something in the set. You start with something in the set and you end with something in the set. You want to produce a number that is in that set. We're going to talk about sets of numbers and operations and what they're closed under. Okay, so determine which equation illustrates the commutative property and explain your choice. So remember, the commutative property of addition states that you change the order. So we want to pick A plus B equals B plus A. And why did we pick that? The order changed. Okay, next, this is going to talk about closure. Ramon said that the set of integers is not closed, which means it's open, for at least one of the basic operations: addition, subtraction, multiplication, or division. Determine if the set of integers is open or closed for each of the 4 basic operations. So the numbers we're dealing with are the set of integers. So you want to think, operations on integers, do they produce integers? So you can try it out with some integers. Addition, I want to practice adding some integers together and see if they produce integers. So you should try positives, negatives, and don't forget about 0. So say you add, 2 plus 0 produces 2. Well, when I added those 2 integers, I got an integer in the set. Negative 2 plus 0 also produces -2, a number in the set. Negative 2 plus 1 produces -1. That's another integer in the set. And what if I tried 2 negatives? Negative 2 plus -1 will produce -3, which is also in the set. So yes, I would say integers are closed under addition. Integers are closed under addition because when you add 2 integers together, you get back an integer, a number in the set. So try subtraction. When you subtract 2 integers, do you produce another integer? -1 minus 3 is -4. 1 minus 3 would be -2. 3 minus 1 would be 2. And you could try it with 0. 4 minus 0 would be 4. Or 0 minus 4 would be -4. So each time I subtract integers, I get an integer. So integers are closed under subtraction. So next is multiplication. When we multiply integers, do we produce an integer? -2 times 0 is 0. That's an integer. 2 times 0 is 0. That's an integer. And we try 2 positives. 3 times 3 is 9. That's an integer. How about -3 times 2? That's -6. That's an integer. And what if I did 2 negatives? -2 times -4 is +8. That's an integer. So I would say integers are closed under multiplication. And then the last one, division. When you divide integers, do they produce integers? Careful when you divide by 0. I have a feeling this one is going to be open. You could divide -8 by 2 and get -4. That's an integer. But if I flip it and do 2 divided by -8, I'm going to get a fraction. I'm going to get -1/4, which is equivalent to -0.25, which is not an integer. And you're going to run into problems when you try dividing something by 0 because that is undefined. So integers are open under division. Because when you divide integers, you do not always get back an integer. So integers are open under division. Okay, so flip your sheet over. A couple more examples. Which expression is an example of the associative property? So remember the associative property, order doesn't change, but the grouping does. Correct choice should be 1. Which equation illustrates the distributive property for real numbers? So remember, when you distribute, you're multiplying numbers, you're passing out numbers, or you're handing out a number. So 4 should be your correct choice. 5, if a and b are integers, which equation is always true? 4, that's an example of the commutative property of addition. 6, under which operation is the set -1, 0, 1 closed? So that is a specific set of numbers. They're giving you a specific set. You want to try multiplying, adding, dividing, subtracting. Well, you should pretty much be able to rule out division because of the 0. And when you divide by 0, it's going to be undefined. So when you multiply numbers in that set, do you produce numbers in that set? Or when you add numbers in that set, do you get a number in that set? Or when you subtract? Subtraction's not going to work because if you do -1 minus 1, you're going to get -2. And that's not in the set. So it's not closed under subtraction, and it's definitely not closed under division because we talked about dividing by 0 being undefined. So you're left with multiplication or addition. Choice is going to be multiplication because the addition is not going to work. If you take 1 plus 1, you're going to get 2, and that's not in the set. Or if you take -1 plus -1, you're going to get -2, and that's not in the set. But that set will be closed under multiplication. So next, under which operation is the set of odd integers closed? Well, we know it's not going to be division. So you want to practice the set of odd numbers. If you add, odd integers. If you add some odd integers together, do you get an odd integer? Well, let's see. If I do -5 plus 3, that gives me -2, and that's not an odd integer. What if I do -5 minus 3? I get -8. Also not an odd integer. And we know division isn't going to work, so our answer is going to be multiplication. If you multiply two odd integers, you're going to get an odd integer. So you want to reproduce a number that's in the set. 8. Which set is closed under division? Well, we know integers are not closed under division. We proved that on the front. And since whole numbers are types of integers, they're not going to be closed under division. And counting numbers are types of whole numbers, and they're not going to be closed under division. So the only answer is the given set of 1, because 1 divided by 1 will be 1. 9. Which equation illustrates the distributive property of multiplication over addition? Check your numbers. Correct answer should be 2. Okay, determine if each of the following sets is closed under division. Justify your answer. So natural numbers, well, this is an example we just talked about on the multiple choice. When you divide natural numbers, do you reproduce natural numbers? Answer is going to be no. Give me an example. Well, if I take 1 and divide it by 2, I get 0.5, which is not a natural number. So this set is determined if each of the following sets is closed under division. So not closed under division, which means it's open. You could say it's not closed or you could say it's open. So the set of integers, well, we know this is already false. We proved this on the front. If you divide integers, you're not always going to get an integer. I could do -2 divided by 3, and I'm going to get -0.6 repeating. So also not closed under division. Big thing here is giving an example of why it's not closed. Rational numbers. Well, there's tons of rational numbers out there, but 0 will give you problems. If you do 5 divided by 0, that's going to be undefined. So rational numbers are not closed under division. And the last one on this example is the set of the number that just contains 1. So if you divide 1 by 1, you get 1. So this set is closed under division. And then the last one, the symbols. The equation, it looks like a little asterisk, parentheses, triangle plus heart equals asterisk triangle plus asterisk heart is an example of the what law? That's an example of the distributive property. We'll learn more about other properties tomorrow.